a practice in chain rule. We practiced a lot on last time with the yummy cookie brownies. Now anytime I say you try, please pause the video and work out the solution, and then start the video back up and you can check your answer. So once again, we are doing the chain rule. I'm still trying to learn new technology, so bear with me, my colors might be off a bit. But let's start this problem where it says sine 2x. I'm going to go to black first. And to find the derivative, we're going to have to start with the outer function, which is the sine function. So I'm going to say the derivative, we're doing the derivative of sine is going to be a cosine. And we're going to keep the inner function the same. And I'm going to make that color pink. And I'm going to say, here's my inner function. We have not messed with that. 2x plus 1. And then I'm going to multiply by the derivative of that inner function, which is a 2. So that problem is done. The only simplification you can actually do is to pull that 2 to the front and say my answer is 2 cosine 2x plus 1. And we are done. So I would like you guys to try. Let's change it back to black. And say we're going to find the derivative of y equals tangent of 3x squared. Tangent of 3x squared. Please find y prime. Pause the video at this time and work out the solution. Once you're done, restart up the video and go to the answer. Hey, you're supposed to pause. If you did pause and you agree with me, the outer function is tan, so the derivative is secant squared, keeping the 3x squared the same. And then you multiply by the derivative of the 3x squared, which I put here as 6x. Like I said, there's not much simplification you can do, so good job. Give yourself a pat on the back if you got that one right. Let's try this one. Now with this one, I like to rewrite it first to get rid of that radical. So I'm going to try my colors and say the outer function is black, and I'm going to rewrite that radical as, let's see here, my pen's acting up, something raised to the 1/2 power. And then I have an inner function, and let's say it's going to be 3x to the 4th plus e to the x. So I can clearly see the outer function is to the power of 1/2. The inner function is the stuff in blue. Let's change it back to black for right now to say y prime is equal to, bring the 1/2 down, keeping the inside the same, and we're going to reduce that exponent. Whoops, it just froze. By 1. And then we're going to keep the inside the same. So I'll say 3x4 plus e to the x. And now we're going to take the derivative of that inner function, bringing the 4 down. Whoops. 12x3 plus e to the x. The derivative of e to the x stays e to the x, so that's a pretty nice one. Now, like I said, you could simplify this if you really wanted to and said this y prime is equal to, bring the negative exponent to the bottom. And then we're going to keep that top parenthesis, 12x to the 3rd plus e to the x up in the numerator. The 2 in the fraction out in front is still going to stay in the bottom. And I'm going to move the 3x4 plus e to the x to the 1/2 power. And that could be your simplified answer. Okay, so now why don't you guys try this one with y equals the square root of 1 divided by 4x to the 3rd plus e to the x. At this time, pause the video once again, try the problem on your own, and see if you can get the right answer. There's the solution. Pause it again if you want to look through it. And here's the last problem. I said we have e to the cosine 2x. E to the something is the outer function, so the derivative of the outer is just the same exact thing for cosine, or sorry, for e to the cosine 2x. So the derivative of your f is out here. The derivative of the next inner function is going to be cosine, so that's where the negative sign came from, keeping the 2x the same. And then finally we can take the derivative of 2x and put a 2. There's not much to do besides using the commutative property and putting the negative 2 cosine sine 2x in the front and the e to the cosine 2x in the back. So like I said, the chain rule is pretty powerful, but just remember it's the derivative of the outer, keeping the original inside the same. And change it to pretty pink. And then we're going to multiply by the derivative of the inner function, keeping that u the same. And then finally take the derivative of u. I hope this helped. Go practice your homework.